Hi there. Welcome to Xamarin University. My name is Mark Smith, and this is IOS110, Fundamentals of TableViews. Before we begin, make sure that you download all the materials from the website. You can see the link here on the screen. You'll need those as we go through the exercises. We're going to talk about four things. First, we're going to quickly look at the table view and how it's used in iOS applications, and then how you can add them into your own applications. Next, we'll check out some of the built-in cell styles that you can use to present information in a row. And then we'll look at adding some simple behavior to the application so that when you tap on a row or interact with it, you can see different behaviors occur. And finally, we're going to go over an important optimization that you should always do when working with table views called cell reuse. So let's get started by looking at what components make up a table view. We've got four things that we want to look at. First, we're going to actually look at the table view itself and the different places that you might see them in iOS applications. Next, we're going to look at the different classes that actually make up a table view inside your application so that you understand how it's integrated into an app. And then we're going to actually add a table view into an application. And then we're going to populate it with data. So table views are used in all kinds of applications. You'll find table views in the Mail app, Twitter, Messages, pretty much anything that presents a list of data. In fact, you'll be hard-pressed to find an application that doesn't use a table view that isn't a game. The reason they're so common is because the display of the iPhone is very limited, so having a scrolling interactive list of rows of data is a very useful UI paradigm. We see the same sorts of UI in other environments as well. For example, in Windows, we often use a list box, and in Android, we'll use a list view. However, while table views are very common, they're also very customizable. You can make it visually look different in a variety of ways and provide different types of user interactions with them. We're going to focus on the basics in this class, the fundamentals, and then we'll follow up with two other classes that will dive into customizations and controlling the interactions. Let's get started by just looking at different applications that actually have a table view in them. Here you can see an iPhone. I've got a lot of apps installed on here, and I'm just going to flip through a few of them just to kind of see what's in it. Let's start with the Settings app. You can see in the Settings app that we get a scrollable list of features that we can change settings on. And you can also see that each row is visually distinct. And when I tap on a row, for instance, General, it actually gives me a navigation. And in fact, I can even see a little disclosure triangle called a chevron that's listed on the right side of the row. That visually indicates that there's a navigation ability when I tap on the row that it's going to take me to a detail screen. So this is using a table view to represent that data. Let's look at another example. Here's a custom calendar application called Fantastical. Notice that we have a scrollable list across the top that shows me the dates, but then I get details here along the bottom, which is a scrollable list that also has a customized view showing me the event and the time and some details about that event along with the little colored circle. This also is a table view. Anytime you see a scrollable list of rows like this, you can generally assume that it's probably a table view that's been integrated into this. Now, an interesting thing about this particular UI here is notice that the table view itself is not the full screen, unlike the Settings app where it took up all of the screen itself. In this case here, you can see that the table view is actually just a part of the screen. And so you can use table views in a variety of different ways. Here's another example, the Messages app. Notice here I have a simple list of rows that generally just has text and some minor details along with a disclosure triangle. So for example, I can select one of these items and then get the details about those messages. And in fact, if we had a conversation here, for instance here you can see I have a conversation that's actually represented, we could actually display this as a table view as well, because again is a scrollable list of items, and the fact that the rows are represented as little bubbles is irrelevant because I can create my own custom cells for that. Let's look at one more example, the weather app. When I go to the details for the weather app, you can see that I get a little scrollable list here as well. And again, this could easily be done with the table view. So you can see the table views are very customizable and used in a lot of different application styles. Now that we've seen a few applications, let's look at the components of the table view itself. First, the table view is actually a view class in iOS named UI TableView. This is what actually visualizes the data, and it presents this data in rows, and it wraps all those rows in a UI scroll view to provide the scrolling experience. As you saw in the demonstration, you can have a table view take up the entire screen. This is quite common, particularly on smaller devices. Or you can have it just be a section of a screen where other sibling views are presenting data around the scrolling table view itself. Each row in the table view is actually a subview which uses the class UI TableView cell. We often just call these rows cells. iOS provides several built-in cell styles, which we'll look at in a moment. These allow you to mix text and images together, or you can create fully custom cells where the subviews are created and organized however you like them to be. Each row in the table view is often the same height. These are called fixed height rows. Or you can vary the height on a row-by-row basis. This used to be a bit tricky to pull off, but in iOS 8, Apple moved most of that work and calculation into the table view itself. We'll look at that topic in depth when we talk about customizing table view cells. The cell has several responsibilities. First, it renders the data. For the built-in cell styles, this is done by setting properties on pre-created subviews in the cell itself. These are exposed through properties in Xamarin iOS. Second, the cell is also responsible for responding to user interaction, taps, swipes, etc., and either invoking some system behavior or bubbling it up to the application to provide a response. We can add a table view into our application in two different ways, through code or through Storyboard Designer. Adding a table view in code involves creating a new UI TableView object and setting the frame to position it. Then you'll often add constraints or a resizing mask to provide layout behavior. We're not showing that code here because it's a bit complicated. And then finally, once you've got it all set up the way you want it, you add it to a view collection. That's what this add method does here. This sort of code, as you can see here, would be the approach you would take if the table view was just a portion of the UI you want to display. If you'd like to display a screen where the table view takes up the whole view, then there's another code approach you can take. This involves the UI TableView controller. This is a built-in view controller class where the child view is a UI TableView. It's exposed through a TableView property, as you can see here. By just deriving from UI TableView controller, you can get your table view created for you. And there are secondary benefits that you'll see in just a moment when we start populating this with data. The other way is to add a table view into the UI with the UI designer. You can use either Xcode or the built-in iOS designer in Xamarin Studio or Visual Studio. In either case, you will find the table view control and the table view controller in the toolbox. You can drag a table view into an existing view controller on the storyboard. This would have the same effect as the first code block we looked at. Or you can drag an entire table view controller onto the designer surface, which will create a brand new screen. This would be the same as the second block of code we just looked at. Let's try both of these approaches out. So we're going to do an exercise together. Let's switch over to Xamarin Studio or Visual Studio and actually build an application that uses a table view. The purpose of this is to get a table view into our application through both code and the designer. So I'm looking at the Start Here HTML that comes with the lab materials. You can see that here are our 4 objectives. Here's the copy of the slides if you'd like to go through them on your own. And this is the exercise that we're going to start with, to add a table view to an application. You can click the exercise link to actually walk through the step-by-step instructions, as well as the challenge that gives you the high-level exercise that we're going to do. So here you can see we've got 4 basic steps. Now, this is a recorded video. However, In the live class, this would be a group exercise that would be done together with the class and the instructor. I'm going to encourage you right now to just stop the video and use these 4 high-level points to work through the exercise and then fill in any gaps by going to the step-by-step instructions that are listed down below. Once you've completed that, come back to the video and I'll walk through it with you to actually go through the exercise. I'm going to be using Xamarin Studio for the Mac. You can also use Visual Studio as long as you have a Mac to be used as your build host. Either one will work, and everything that I do here can be done in Visual Studio in exactly the same fashion. Now, our goal with this will be to create a new iOS application and add a UI table view. First, we're going to do it in code, and then we're going to do it with the Storyboard Designer, just to show you both approaches. So I'm going to start by creating a new solution. I'm going to go to iOS, Application, and I'm just going to pick the Single View app here to be able to create a single view that's already present. We're going to click Next. Let's go ahead and name our application Mailbox. Notice that the identifier is automatically set for us to be com.xamarin.mailbox. This, of course, can be changed, and it correlates to your bundle ID that's going to be associated with the application itself. I'm going to go ahead and leave it as both an iPad and iPhone app, but we won't be using this support in the application itself. Feel free to uncheck iPad if you prefer to just work with a smaller display. And I'm going to leave my target as iOS 8.3 and click Next. I then have the option of changing my project name, the solution name, and deciding where it's going to be placed. In this case, I'm going to leave it on the desktop. I'm going to go ahead and click Create. And it's going to give me my application. Now, because we picked the single view application, we're going to have a single view controller present in our source. And you can see it's here, viewcontroller.cs. So this is the source file representing our UI view controller. If we open this up, you can see it derives just from the basic UI view controller. Now, our goal is going to be to add a table view in code. And so I'm going to go ahead and use this UI view controller here as the owner for my table view. And generally speaking, anytime you add anything into your UI, you're very likely going to do it in the viewDidLoad override. And the template, nicely enough, has already overridden this, although I could have just typed in override to find this method as well. And so what I'm going to do here is create a new UI table view object and then access it from this viewDidLoad. So I'm going to go ahead and instantiate it here and then configure it from within the viewDidLoad. Now I want to go ahead and be able to use this table view from outside the viewDidLoad method, and so I'm going to create a field to actually hold on to it. And so I'm just going to call this method TableView, and then in my viewDidLoad, let's just go ahead and instantiate it. So we'll say new UI table view, and I need to pass it a frame. The frame just represents where I'm visually going to locate this. And typically what you'll do is either pick a subset of your parent view, or you'll use the entire frame for your parent view, which is what I'm going to do in this case. So I'm just going to take the view property from the view controller, grab the frame from that, and pass that in as the designated frame for the table view itself. Then the next thing that I have to do is I have to add this table view into my UI structure. And there's actually 3 different ways we could do this. I can type this view add, and notice this just takes a subview, a UI view child, and so we would say table view, place it in here, or alternatively, I can also do this dot add. So notice there's also an add method here where I can pass in the table view. It turns out that this method is exactly the same as the prior one that we just did. In fact, if you were to take a IL decompiler and look at the method implementation, you'll find that it just reaches into the view property and adds the option into the view itself. Finally, there's a third way to do it, which is I can say this.view.add subview. This is the approach that is actually exposed in iOS. And so if you did this in iOS, you would use this add subview. The reason why Xamarin iOS includes add methods, the first 2 approaches here, is so that you can use a collection initializer syntax. It turns out that C#, as long as you have an add method, will let you then use the handy property initializer style to be able to add in multiple things into the table or into the view hierarchy. And so any one of these 3 approaches will work. I'll just leave the last one in just as the approach that we're going to use here. So let's go ahead and run this just to see what happens. I'm going to use my simulator here with an iPhone 4S just because it's a little smaller in terms of the view. But any simulator would work, or you could even deploy this to a device to see what it looks like. Keep in mind, all we've done at this point is just inserted a view, the table view, into our view hierarchy. Let me drop the scale on this just a bit so we can see it. And so you can see here I have my table view. It went ahead and inserted separator lines. You can see that it is scrollable as I kind of move up and down. Now, one thing that's not going to work properly right now is if I rotate the device, you can notice that my lines aren't going all the way across. And this is because we didn't set any constraints and we didn't set any mask onto this, any layout mask, to be able to properly resize this. We're not going to mess with that in this class here, but I do encourage you to take IOS110, which goes through the process of using auto layout and constraints to be able to magically make your application size properly as it moves through different rotations, and also to properly size as it goes between the different device styles. That wouldn't be an issue in this particular case because we're initially adding it in, and therefore if I was on an iPhone 6 Plus, for example, it would automatically take the full frame. But if, for example, I had other subviews that were placed in here, I would certainly want to add in constraints to make sure that this table view got sized properly in conjunction with other views that are placed there. Okay, so we can see that it is working. So if you're interested in dealing with constraints, the lab instructions do have some constraints you can add in code, and I'll let you go and do that if you're interested in kind of seeing what that approach would look like. But let's actually do this with the designer. Let's take a different approach and use the storyboard designer to actually create our UI. So I'm going to go ahead and double click on main.storyboard here to open this up in the iOS designer right here in Xamarin Studio. You can do the same thing in Visual Studio, but remember you'll need that build host because it's going to delegate a lot of the graphic pieces over to the build host to populate the controllers and objects and get the appropriate things in the toolbox. Okay, so let me zoom this out just a little bit so I can kind of see what's happening here. You can see I have my single view controller. This is the main view controller that was part of my app. And so this is the single screen that we have inside the application right now. What I'm going to do is go and find a TableView controller inside my toolbox. And so here it is right here. And I'm going to drag it out and just drop it into the designer. Now remember from the lecture, the TableView controller already has a table view in it. So we don't need to create the table view in this particular case. Instead, I can simply use the TableView controller and I get my table view already created. And you can certainly see that it is here along with a single cell that we could use to kind of design what our cell will look like. We'll talk about that a little bit later. So I could have also, if I'd wanted to, drag a table view into my existing view. That would have duplicated what we did in code. And so if you scroll down here into the data views area, you'll find there is a table view, and you could drag and drop it right here onto the view controller, and then we could create an outlet for it that maps it to a property by giving it a name, and that would then let us control it in code, just like we did just a moment ago where we actually created one in code and just added it as a subview. It would be the identical same steps, just done through the storyboard designer. But we're going to use this TableView controller version instead to be able to work with this. This is a second screen in my design, but what I want to do is make this the primary screen so it's the initial one that we display. To do that, I'm going to go over here to this little marker and I'm just going to drag it from that first screen to this second screen. That marker is what actually decides what the primary view controller is. In other words, the initial screen that's displayed from the storyboard. I can also change that by clicking on down here on the bar underneath the table view and scrolling down a little bit into the view controller properties, and here in the properties you can see there's a checkbox, is initial view controller. This will then move this little marker onto this particular view controller, indicating it's the first screen that we're going to display. So then the last thing that we need to do is we need to kind of hook this table view up with some code. Now the way we're going to do that is we drag this onto our design surface, but we don't actually have any class that's behind this. And so notice in my properties under identity, which is the first section, we can actually define a specific class to use here. And so I'm just going to call this table TableView controller and hit enter. When I do that, Xamarin Studio or Visual Studio are going to create a code behind file for me to represent this class that I can then begin to add my code into. So that would include my behavior, and in this particular case, in just a moment when we come back to this in an individual exercise, we're going to be adding in some data and things like that into the table view as well. So if I go back and I look at my Solution Explorer here, you'll see that I now have a TableViewController.cs, and I also have a TableViewController.designer.cs. This is the design time file that backs this, so anything that I set in here would potentially be recorded in this design time file if it requires some sort of code behind. If we open this up, you can see that it is just simply my class name, TableViewController, that I typed in as the name, and it derives from UI TableViewController. And so this would be how I would then begin to use this as a UI TableViewController. I'm going to run this one last time, and just to make sure that this is actually the file that I'm using, let's go back to that storyboard and specifically go back to my table view here, and let's just set the separator style to be a different color. Let's just make it blue instead of the default gray that we're using in the original table view. So I'm going to launch this in the simulator, and what we should see is then our table view with our blue separators, and so we can tell that this is actually coming from our second screen that we added into the design. Now before I go back to the slides, let me just reset that back to the default since I just want to use gray. I just wanted to verify that we were using the correct screen. So you've seen how to create a Xamarin iOS application and then add a table view in both code by simply creating a table view in code and then using add or add subview either on the view controller or on the view to be able to then add that into the view hierarchy, or in the designer using the table view controller instance. So let's go back to the slides and talk about how we can now populate this with data. Now that we've got a table view, we need to add some data into it. To start with, the data generally always comes from some kind of internal data in our app. This might be a complex object, a string, or pretty much anything we want it to be. It could be internally generated, like a task, or it might come from some external source, such as a web service. In any case, to take the internal data and to create rows from it, we need a data source. The data source is what creates a cell for each item. It knows about the data, it knows the shape and the elements within it, and it knows how to map those pieces to work out a visual cell that will be displayed to the user. In the same fashion, when the user interacts with the data, the cell in the table view will inform the application code. This is done through a delegate class called UI TableView Delegate. The delegate in this case has a set of callback methods which we need to implement and associate with the table view to receive interaction notifications. We won't be looking too deeply at the delegate in this class. We're going to save that for the next one where we talk about editing and deleting and reordering for full coverage. However, you will see how to respond to an activation request. To function properly, the table view needs both the data source and the delegate. These are both protocols in iOS. That's a special sort of interface that you don't have to implement all the methods and some default behaviors provided for you. It's kind of like a mixture between an interface and an abstract class. Since we don't have an equivalent construct in C#, these are both mapped to an abstract class, which you derive from to provide the implementation. With this approach, you would create a data source class which maps the data onto the cell, and a delegate class which provides the interaction behavior. Instances of these two classes would then be set on the table view through properties. This approach is useful if you want to share the data or the behavior with another table view, but not necessarily both at the same time. This is the way iOS works, and any native sample you look at would have implemented both of the protocols independently, although possibly they'll do it on the same class since Swift and Objective-C both support protocols. It's not terribly convenient in C# however, because we'd have to create two separate classes. And it's not generally the most common requirement either, so in Xamarin, there's a shortcut we can take. Instead of creating two classes, we can derive from a single class which aggregates the data and the behavior together. This class is known as the UI TableView source, and it's also an abstract class that can be implemented in order to display data in the table and provide the interactivity and notifications. Virtual methods and properties are mapped to the underlying iOS protocols that are used to then drive the table view. This is a far more common approach than splitting out into two separate classes, and this is the approach we're going to focus on in this class. But keep in mind that you can separate them if you prefer, since that's how the underlying system is actually modeled. This aggregate object is only available in Xamarin. You won't find it in Apple's documentation. So we create a new derived class from the UI TableView source, and we override virtual methods to provide the data and the behavior. You then create an instance of the class and assign it to the source property on the table view that it's applying data to. Here, we're accessing the table view through a field or perhaps a property on our view controller. And we're assigning the source property on the table view to be the actual table view source that we've created. This approach is quite common, and it lets you pass the data source around and tie it to different table views, sharing both the data and behavior together. There's one other approach we should look at. I mentioned earlier that there's a second benefit to using the TableView controller, and this is it. Recall that the UI TableView controller is a ready-to-use view controller that has a table view hard-coded as its view. You can access the UI TableView through a convenient TableView property. In native Objective-C or Swift, it's quite common to implement the protocol messages directly on the view controller. And so Xamarin provides for that exact scenario through the TableView controller. It implements both the data source and the delegate methods as virtual methods on the class. And you can directly override the methods on this class to put your controller, data, and behavior all in one place. This approach is useful when the table view takes up the entire screen. So let's test our knowledge and see where we've come. Question number 1. The UI TableView class is A, a view that represents a single cell or row in a table view, B, a view that contains a collection of cells inside a scrolling container, C, a class that provides notifications about user activity from a table, or D, none of the above. The answer is, of course, B. A table view is a view that contains a collection of cells inside a scrolling container. Question number 2. The UI TableView delegate is used to A, handle converting raw data individual cells, B, provide a type-safe callback to the table view, C, handle events and notifications from the table view, or D, all of the above. The answer is C. The UI TableView delegate is used to handle events and notifications from the table view. Question number 3. You can implement the data source and the delegate, A, as separate classes, UI TableView data source and UI TableView delegate, B, as a single class, UI TableView source, or C, by overriding methods on the UI TableView controller directly. Finally, D, all of the above. And the answer is D. You can implement the data source and delegate through any one of these methods. The data used to populate a table view can be pretty much anything. It's generally always some kind of collection or array. Here you can see we're using an array of strings. The data is accessed through some kind of data access layer, or it could be held directly by the data source object. In this case, we're using a TableView controller. It really doesn't matter which approach we use to provide the data. The TableView controller, the TableView source, or a separate data source and a delegate. The override methods that I'm about to show you are identical in every single case. The two primary methods we must provide on the data source are rowsInSection and getCell. There are other methods we can override as well, but these two are required, and without them the table view won't function properly. So let's look in detail at each one of these. rowsInSection is used to provide the total number of rows for the data that we're trying to display. This allows the table view to properly set up the scrolling view so it knows exactly how far the data is going to scroll. The method has passed two parameters, the table view and the section. The section is the area within the table view that we're interested in. Table views can group data into different sections, and each section has its own count. You support multiple sections by overriding another method named, appropriately enough, number of sections. If you don't implement it, then it assumes there's just one section, and this parameter will always be 0. Otherwise, it's a 0-based index into the section of the table view that we're trying to determine the size for. This method is responsible for returning the number of rows, typically by consulting some internal data source that's being presented. Notice that the parameter passed and returned are both ints. This is a special integer type that was introduced in the unified Xamarin iOS API that allows the code to be properly compiled for both 32-bit and 64-bit execution. Unlike a normal system int32, which is always 32-bit, the int value actually changes size based upon the target. As you can see, you can return a normal integer value without an explicit cast, and the compiler understands that these are integers and will properly upcast from 32-bit to 64-bit if necessary. The second method you must implement is the getCell method. This method is responsible for creating and returning a UI TableView cell that's going to be used to display a given row. You can see that it takes two parameters as input. Again, the table view that we're working with and an index path. Remember, the table view supports sections. This is actually an iOS object which includes both the row index and the section index for the row that we're trying to display. If you only have a single section, then you only need the row property from this object. Our job in this method is to look up the specific internal data item that's being requested, as you can see here, the names array, and then create a new UI TableView cell to display the data and return it back in response. As part of that cell creation, this method must fill in all the details for the cell, setting text properties, images, and anything else that needs to be displayed from the internal data object. The one subview which will always be present is the text label subview. You should always set the text for the row, as this is the primary string that's going to be displayed inside the cell. So let's give this a shot in our code. We're back in our Start Here HTML file, and if we scroll down just a little bit, you'll find exercise 2 populating a table view. If you click the exercise link, it'll take you to the instructions for completing this lab exercise. And there's a couple of steps that you'll do. First, we're going to be adding a data source to our table view, to the existing mailbox application that we created in the first exercise. To do that, you're going to need two things. You're going to need an actual data source itself. That's pre-supplied in the form of a source file called emailserver.cs. This is just a simple C# class that will generate emails for you that you'll be able to then populate your table view with. You're also going to have to add a words.txt data file to the application. This is going to be placed into your resources folder, and it will simply be a resource that the email server expects to be able to generate fake emails from. It's essentially a lorem ipsum sort of text file that it will randomly pull words out of in order to generate fake emails. Once you've got both of these in your project, you'll then turn to actually creating the TableView source. We're going to do this in two different ways. In both mechanisms, we're going to implement the same two methods, rows in section and getCell. Recall from the lecture portion that rows in section returns the total number of items that we want to present into the table view, and then getCell is called to actually render a UI TableView cell for each specific item on an item-by-item basis. Go ahead and pause the video here and go through the exercise using the 4 challenge steps and then filling in with the step-by-step instructions below. And then when you come back, we'll walk through the exercise together. So here we are back in Xamarin Studio. As I mentioned, there's two things that we're going to have to do to this application first in order to actually get our data. There's two files that are in the part02 resources folder, emailserver.cs and words.txt, which need to be added to this project. Let's start with the words.txt. That's going to be placed into our resources folder. Resources are used for files and things like that that need to be included within our project but aren't necessarily source code that get compiled. We can add things to resources by right-clicking on it, selecting Add, and then Add Files. When this comes up, go into your Lab Materials folder, Part 02 Resources, and select words.txt, and just click Open. You'll want to go ahead and copy this file into the directory. This dialog will only show up for Xamarin Studio. In Visual Studio, you'll use the exact same process, but it will automatically just copy into the folder. Once you've done that, you should be able to expand this and find words.txt. In the properties for this file, you'll find that it's actually set as a bundle resource. You can see that in Xamarin Studio by either going to Properties, or you can see it really quickly with Build Action, and you can see that it is set to bundle resource. Again, it will be the same in Visual Studio. This file is just a list of words. It's essentially a dictionary that we're going to use to be able to create our emails from. The second thing that we need to add to this is our email server code. And so I'm going to go ahead and again right-click on this in order to add an existing file, which will be emailserver.cs. And again, I'm going to copy it. If we open up email server, you can see it's just a class, and it has a couple of methods on it. Specifically, the one that we're interested in is this refresh method that will generate 10 emails. And notice that it calls that as part of the constructor, so we'll initially get 10 emails inside of a collection called email. So this email collection is what we're actually going to work with in order to populate our list view. So now that we have those two files, let's actually look and see what it would take to actually add this into our system. Let's start with the TableView controller approach. If I open up the TableView controller, I can then come into the source file and I can implement our two methods. If you just type override, you can start typing the method rows in section, and you can see that it shows up and I can hit enter to get it to complete. We don't actually want to do the return from the base class. Instead, what we really want to do here is instantiate our email server and get the total number of emails that are in that list. So let's create a field up here called email server. Let's go ahead and create it. And then down here in our rows and section, we can simply say return emailserver.emails.count. And so that's the total number of emails that we have. And that's all we need to do. Remember, we aren't creating multiple sections, and so we can ignore this second parameter altogether. This will always be 0. Then we need to implement the getCell method. Again, we don't want to return the base class. The purpose of getCell is to create a new UI TableView cell. So let's do that first. And notice that it takes as its constructor a frame. And so I'm just going to pass in cgrect empty to indicate that we don't have a frame here, and we'll just let the TableView cell take care of actually sizing it appropriately. Then we need to look up the specific email that we'd like to represent. And so I'm going to say email item is equal to email server, and I need an index. That's where this index path parameter comes into play. Remember from the lecture that index path has two pieces to it. We have the section and the row. Now remember, we've only got one section, so section will always be 0 in this case. And so we're just going to go against the row, which is an integer. So we'll go ahead and pick up the specific email item from the email server. And this needs to be off of the email property. And once we have that, we can then set some text into our UI TableView cell. So the one property that we always have access to is text label. This will always be filled out. And we can set the text property on the text label to be the email item dot, and then you can see we have a set of properties from the email item, and in this particular case I'm just going to set it to the subject. I can then return the cell back to iOS. This will then put this particular cell into my table view, and I'll see it presented into the UI. So we can now run this application to see what it does. And you can see here that we've got our mailbox app, and in here we've got a list of emails. These are just sample subjects that have been created based upon that dictionary. So let me go ahead and stop this. So that's the table view controller approach. Let's try it using our original view controller where we created the table view in code. Now to do this, because we're not using a view controller, or a table view controller rather, we're going to need to create a TableView source. And so what we're going to do is create a new UI TableView source. We can place this, it's just a class, we'll derive from it. We can place it inside this source file, or we could put it in a separate source file if we wanted to. And the idea is that this would then provide the data for the table view when it's being presented. So I'm just going to go ahead and place it as an inner class inside this view controller right here, just so that we can see it all on the same screen. I'll call it email server data source, and this will derive from UI TableView source. Now, we've got exactly the same methods here in the UI TableView source. And so, in fact, we can just go to our TableView controller, copy our email server, and all of the methods that we implemented, and then paste them in right here. I don't need the constructor, but the other two methods are perfectly fine. So let me just go ahead and pick up the two namespaces that we're missing. I'm using Alt-Enter or Option-Enter on the Mac in order to get to both of those. And the implementation is going to be identical. So now I have my data source. I can then come to my table view, and we can say TableView.source is equal to a new email server data source. And so the source property is wired up to an implementation of this UI TableView source, and the UI TableView source typically will control the data and implement my methods row and section and getCell. This then makes this class reusable. So for example, if I wanted to present this same data in multiple table views, I could do that by sharing this data source. That's one of the advantages to using a separated data source like this over, say, a table view controller like what we did just a moment ago. So once I've got this, I can now run this application. But before I do that, let's just switch it so that it's the correct view, because remember, right now we're using that table view controller. And so I'm going to go ahead and click on the view controller here, and we'll use the other approach that I showed you earlier where we just check this is initial view controller, and notice my little arrow moves over to this view here. I'm going to save that and then run it again. And now this will be the initially presented screen. And as before, we should see data that shows up inside my table view. And so you can see that it is working. So that's a table view driven from a TableView source. So now you've kind of seen the basics of integrating a table view into your application. We need to supply a data source that's going to actually populate the table view with data, and we need to supply a delegate which allows us to actually implement notifications. The table source is where we actually get the rows and section and the getCell method. So both of these overrides actually come from the TableView source. We have a variety of ways we can supply these to a table view. We can use them independently by implementing two different classes and then supplying property values to the table view to point them at both of those implementations. Or we can use a UI TableView source which aggregates those two things together and supply it as a single class. Or we can use a UI TableView controller which creates the table view for us and allows us to just override methods right on the table view. So now that we've seen how to add a simple table view into our application, let's start customizing it. We're going to look at two things. The table view has a set of built-in cell styles that we can take advantage of that we can populate with data. You've seen one of these already where we just set the text label. We're going to look at those cell styles, what things are present in them, and then how we can customize them. The UI TableView cell class actually has 4 built-in cell styles that can be used to display data. You've seen the first one, the default view. This has a single line of text with an optional image positioned on the left. If you don't assign an image, then the text is shifted to occupy the whole space. Otherwise, the text is always to the right of the image, taking up the remainder of the cell. We also have a subtitle style. This is the same as default, except a second piece of text in a slightly smaller font is placed below the main text, also stretching out to the end of the cell. The main text and subtitle are always aligned together to the right of any supplied image. The third style is named Value 1. This places the second piece of text on the very right of the cell, sharing the same line as the main text. The main text always takes priority and can even push the second piece of detail text off the row unless you turn on text trimming through the line break mode property. The final style is called Value 2. This just has two pieces of text and is the only built-in style that doesn't support an image. The main text is on the left, and the second piece of text, the detail text, is placed next to it and stretched across the remainder of the cell. We can set the row style when we create the UI TableView cell. It's the first parameter to the constructor and provided in the form of an enumeration, as you can see here. This is done in our getCell implementation, since that's where we create the cell. An important thing to realize here is that the cell style can be selected on a row-by-row basis in the getCell implementation. You don't have to set the same style for every row. Once you have selected the cell style, you can then fill in the details for each cell. This is done through the built-in subviews that are exposed through public properties on the UI TableView cell class. There are three properties of interest. We have the text label property. This is always available and sets the main text line. Remember that can be moved around within the cell itself, depending on the style we select, but it's always there. The second is the detail text label. This is available with all styles except the default style. And then finally we have the image view property. This is available with all styles except Value 2. Now, these properties are always present in the class because they're defined as part of the class, but depending on the style you select, they may or may not be filled in with values. So for example, if we use the default cell style, then the detail text label will be null when we create a cell with that style. Once we've created the cell, we can then begin to fill in the details. Remember that not every subview is available for every style. If you attempt to use a subview where it's not available, you will get a null reference exception because the view isn't created. You can change any properties on the subviews here. Fonts, colors, alignments, line break mode. This is the spot where you'll want to customize all of the visual characteristics of the cell before returning it to iOS to be added into the table view and displayed. So let's give this a shot and try out some of the built-in cell styles. We're back in Start Here to look at exercise number 3, using the built-in cell styles. If we look at the exercise, there's a couple of things you're going to do. You're going to try out each one of the built-in cell styles by modifying your getCell implementation and passing in the appropriate cell style into the constructor. There are 3 different properties that you're going to be working with. The subject property of the email is going to be mapped to text label text. The body will be mapped to detail text label text. And there's a method on the email object called getImage that will create an image that you can assign to the image view image property. So go ahead and try out each one of those styles, and then when you're finished, come back and we'll walk through the exercise together. I've switched over to Xamarin Studio, and I'm going to go ahead and use the TableView controller. I went ahead and modified my application to set this as my startup screen. And what we're going to do is we're going to modify the getCell method and use the constructor that takes a cell style. So notice we've been using this first constructor that just has a frame, but the second constructor actually takes a cell style that we can pass in. And so we're going to start with the default cell style. So we'll say UI TableView cell style dot default, and for the second parameter we're just going to pass a null for now. We'll get back to that a little bit later. So now we've created this cell, and we're going to go ahead and use this in order to populate the data that's actually in the cell. So right now we're setting the subject onto the text label. Now remember, the default has a text label and has an image. And so I'm going to set the image view image property to email item.getImage. This will return me an image that I can simply assign to this. And let's go ahead and run it just to see what happens. So we're just assigning both of these properties. And you can see that I still have my text here. That's the image, or the subject text rather, from the email. But now I have a little image, which is the sender's first initial and last name initial. So basically their first and last name initials put into a little circle here. And if you're interested, that code is just dynamically generating that using the iOS Core Graphics APIs. So you can go examine that method if you're interested in seeing how that is actually done. So that's the default cell style. It simply has a single line of text. And notice they turn on text trimming to make sure that if your text line is too long, it simply gets trimmed with a ... ellipse. And then we have an image to the left. This is actually what we were using before. So when we were just simply using the constructor that took a frame, it was actually using that default cell style. In fact, if I comment out the image and don't bother to set it, you'll see that it looks identical to what it did before when we were just passing in the frame, in that the text will start out at the very beginning of the line and run all the way across. Now, let's try one of the other cell styles. So that's default. The second one we're going to use is subtitle. Subtitle has both of these properties, text label and image view, but it also has a detail text label that we can set. And so let's set that to email item dot body. And let's run it again and see what happens. Now you can see we get the subject in a bolder, larger style text. We have our image, but now we have this smaller text in a slightly smaller font that's actually written underneath this. And the important thing here is that these views are created automatically based upon this cell style, and I can modify them in different ways. For example, we could say the cell detail text label. Let's do this. Let's say detail text label text color is equal to UI color gray. So we'll set the text color to gray for the detail text, and for the text label, let's set the text color to be UI color blue. And let's run it again. And so notice now our title is in blue and our detail text is now a light gray color. So we can modify some of the visual properties of these elements, of these controls that have been created for us in order to kind of customize the cell style the way we like. The third cell style we have is called value 1. And so this also has all three of these styles. And so if we run this, or all three of these controls rather, text label, detail text label, and image, you'll see that we have all three of these, but notice that right now only my title is being shown. And so you're seeing sort of an effect of iOS in that the title itself has a higher priority for display than the detail line. And because that title is relatively long, it's pushing the detail line off because they're sharing the same space. So there's a variety of ways we can actually fix this. We could do this with some constraints. Ideally, what we would use is actually a custom cell. And so when you look at the IOS110 class on building custom cells, you'll be able to see another approach. But let's just fix this in kind of a hacky sort of way. Let's take that cell label and let's actually just make this the email item subject, but let's just pick a substring from 0 to say 20, and then let's just add our ... at the end. We know that all of them are larger than 20 since we can see that, and so we'll just put a ... at the end. This obviously is not ideal, but it'll give you a sense that we can see the detail text item as well. And so now you can see I get my text, and then I can see my detail that's actually being printed over there. So that's value 1. The last style we have is value 2. And I'm going to leave all of these in place just to show you what happens. But remember from the slide, value 2 is a little unique in that it doesn't have an image. And so what's going to happen when I run this is, since I'm attempting to set an image, I'm going to get an exception here of system null reference exception. And you can see that my problem is if I look here at the image view right now is null. And so depending on the style that you select for the cell, it may or may not create all of these different components that are inside the UI TableView cell itself. So these subviews may or may not be present. And when they're not present, they're set to null. And so you can see that because of that, I'm not allowed to set this image. And the way that we would fix this is we could either comment it out, or we could say if cell image view is not equal to null, then go ahead and set it. So if for some reason we're using some sort of dynamic determination to figure out what cell style to use, we can just put some conditionals in here to determine, do we have that property available to us or not, and then decide whether or not to set it. And so now you can see this is value 2, where we have our title on the left, and now the detail text takes priority. All right, and so you can see that we've got our detail text here being printed and taking up the majority of the space. And by the way, notice that they are both in the same size. We still have the color changes taking effect because we changed those in our getCell method, but the font itself is the same size. And so that's the cell styles. You can use these to be able to customize the cell to some degree to tweak it the way you need it to look based upon the data that you're trying to display. So now you've seen how to add a table view into your app, and then how to use different cell styles to get the visual look that you're looking for. Table views are great for scrolling data, and for some apps that may be all that's necessary. But table views are also often used for navigation or selection purposes. So let's look at how we can manage the TableView delegate to provide selection behavior. We're going to look at 3 things. First, there's a special view that we can activate in the TableView cell called an accessory view that allows us to indicate visually that there is some sort of navigation or selection behavior associated with the cell. We're then going to explore some of the delegate methods that are actually called in response to some of that interaction, and how to respond to the interactions on the cell itself, both fully on the cell as well as on the accessory view. So sometimes we'd like to show some kind of accessory view when we interact with the row. iOS has some built-in subviews on the cell that you could turn on and off, which are commonly used to show interactivity such as selection and navigation. The default for each row is going to be no accessory view, or none, when we see the enumeration. But you have 4 basic styles beyond that. First, we can turn on a checkmark view. This can indicate selection when we tap on the row, and is often used when the table view is a piece of a larger view controller to indicate multiple choice selection. Or we can turn on a detail button, which displays the standard information icon at the end of the row. The interesting thing about this is that the button itself can be interacted with independently of the row. There's a separate override on the delegate named accessory button tapped, which is invoked when you tap specifically on the button versus the row itself. Finally, we can turn on a disclosure indicator in the form of a chevron. This is often used to indicate a more details available navigation hint. Users would expect you to navigate to a second screen when you tap on the row, when you have this disclosure indicator turned on. There's one other type, which is detail disclosure button, which combines the last 2 together, giving you both a disclosure chevron as well as a details button. You generally want to set the accessory type in your getCell implementation. When you create the cell, you can indicate the type of accessory view to display by setting the accessory property to one of the known enumerations. Each row can be different, determined completely by some runtime information, or more often by the internal data that's used to populate the cell. Now the question becomes, how do we detect the interaction with the row? For that, we need to turn to the TableView delegate. Remember, the TableView delegate in the class that we implement receives the interaction notifications from the TableView itself. This includes editing operations, delete requests, action swipes, and even simple taps. You can see many of the overridable methods here on the slide. We're only going to explore the primary case, activation through a tap on the cell, but there's another class you can take that actually goes through all of the editing operations, and so if you're interested in supporting editing operations, make sure to take that class. The way that we actually intercept a tap interaction is through the row selected method. This override passes us the table view and the NS index path for the row that's being tapped. Common actions that we might perform here might be to navigate to a new screen, make some view in the cell visible, maybe a check mark, or even highlight the cell using the select row method on the table view. Remember that the delegate is an abstract class in Xamarin, but it's really a protocol class in iOS, And so just like the data source, we have several places where we can implement the overrides. We can use a dedicated delegate class, a TableView source assigned to the source property, or we can use the TableView controller, as you can see here. So let's try out some accessory styles and use selection in our TableView. Here we are back in Start Here, and we're going to scroll all the way down and go to Exercise 4 using accessory styles and row selection. And so here's your challenge. You need to create a new screen that's going to represent the details screen for this email. You're going to show this screen when the user taps the row itself. And so we're going to provide some kind of selection capability and navigate to that second screen using a storyboard segue. Then we're going to set an accessory style on the generated cell so that you'll be able to see a chevron when they actually display the cell itself. Then we're going to change that accessory style to include a little accessory button. So we'll have the accessory button there, and when the user taps the button, we want to show just a UI alert view. So use these high-level steps to work through the exercise and then fill in any details you need using the step-by-step instructions below. And when you've gone through the lab exercise, come back and we'll work through the lab exercise together. Here we are back in Xamarin Studio. We have a couple of things that we want to do. First, because we want to navigate to a new screen by tapping on a row, we need to create that screen in our main storyboard. We could, of course, create this in code as well, so there's nothing stopping us from deriving from View Controller and then providing some sort of UI in code. But it's a lot easier, particularly if it's simple UI, to just simply do it in the designer. Now, we've already got two view controllers here. We've got our table view controller that we've been working with, and then we have this other view controller where we added a table view in code. I'm going to leave that in place. We could just repurpose this and use it, but since the purpose of this lab exercise was to show you how to create a new screen, I'll leave this one in place and actually do that. So I'm going to go to my toolbox and scroll down here to find just the blank view controller, and let me zoom out just a little bit more. And I'm going to drag this into my design surface and drop it in place. This will create a blank view with an associated view controller that then I can use to navigate from a row selected event. So I'm going to go ahead and select the view controller itself so that in my properties I can see that my identity, my class, is UI view controller. And I'm going to give this a new name, Details View Controller. Now this is going to do a couple of things. First, this is going to create a new class, C# source file that's in my solution named Details View Controller, and it's going to associate that class to this view controller that's in my storyboard, so that when I instantiate it specifically from the storyboard, I'll actually get back one of these detailed view controllers. That means that we can put behavior inside this view controller, we can associate controls, and things like that. So let me go ahead and also give this Details View Controller an ID. And so I'm going to go ahead and give it the same ID as the class. And so I'm just going to copy and paste that from class to storyboard ID. The idea behind a storyboard ID is it allows you to look up a specific element that's been created in the storyboard from the storyboard object itself. And so if we can get access to the storyboard, then we can then instantiate one of these view controllers from code through the storyboard object. And so you'll see how to do that in just a moment. Then let's put some UI in here. So first I'm going to go ahead and select the view, and just for fun, let's just set the background to a color so we can always see what it is. And I'm just going to set it to something like maybe a yellow color. Then let's go ahead and put a label on here. So I'm going to find the label and just drag it and put it on here. Now let me kind of zoom in a little bit. The storyboard designer in Xamarin Studio often has some issues when you kind of scale out, particularly in moving things around and trying to position items. And so it's a good idea when you start actually working with the storyboard and trying to position things to zoom in at 100%, just so that you don't have any issues with resizing. And so let's go ahead and take this to 100%. You might notice that this is a square window here, and that's because it's in the adaptive design mode here for iOS 8. And so you can actually change that by clicking on this, and notice that we've got this view as generic. we can actually pull it down and say, you know what, I'm really going to be working with this primarily as an iPhone 4, and so I can change the view to an iPhone 4, and you can see what happens. My label then gets kind of cut off, and that's because we don't have any resizing masks or constraints or anything applied to it. And unlike most UI designers, iOS doesn't bother to move anything for you at all unless you start placing constraints on it. So it just sort of fixes it in position, and because we were using that generic layout, it's going to be way off the edge of the screen. So let's kind of move it here in the center, and then let's put a couple of constraints on this just in order to keep it placed here. The way that you do that is if you click on it one more time, you'll notice that as I just click on it, it switches back and forth between these two modes. One mode is a resizing mode where I can kind of resize the label. The other mode is a constraints mode, and it's denoted by having these little cursor bars on the edges and then a square right in the center. And so what I'm going to do is I'm going to grab this pin spacing and just drag it up to this top layout guide. And I'm also going to go ahead and do the same thing. In fact, let's do this. Let's just center this on the X line, and then it will be positioned here. And notice that it still kind of has this orange line. We can click this last button here to update the frame to sit in here, and then it will be blue, and that's because the label has a known width and height. We just have the word label in here. And so now we're just going to keep it centered, and we're going to keep it positioned. If we double click on this, you can see that it's positioned off of the, let's try that again, let's double click on this one, and you can see it's positioned 73 from the top, so from that top layout guide, that top layout guide being this carrier bar here. And that's fine, I don't need to do anything else. Let's just put a couple other things on this label. I'm going to go ahead and say to center the alignment, and let's set the lines to 0. That means that it can have multiple lines. And then finally, let's go ahead and also set our line breaks to just do a word wrap, and that way it'll wrap around if we have too much content. So that'll be our label, and we'll put our email information here. And if we go up to the very top of the widget properties, we can give this a name. We can call this email details or something like that. That'll create a field in my code behind, and that works specifically because I gave this a class. And so if you don't have a class assigned to this, then you can't create code behind fields because there's nothing to map them to. So you need to make sure to do that first. Then we need some way to get back from this screen. So we're going to navigate to the screen to display some email details. Let's provide some way to actually go backwards, and we'll do that just through a regular button here. And so I'm going to go ahead and put a button into the UI, and let's go ahead and change the text for this to be go back. So let's do the same thing with this one. Let's put some constraints on it. I'm going to go ahead and center it vertically or horizontally rather, and then let's go ahead and place it onto the bottom layout guide. And so you can see now that, again, I have this orange rectangle, but I can click that third button in order to position it in the right spot. And then let's go ahead and make sure that we have enough space for this. And so I'm just going to go ahead and kind of drag this out a little bit so that we have enough space to actually display the data. And this last one here is actually a width constraint. And so I'm going to click that in order to set a width constraint so that we take up this entire width here. And it looks like I misspelled back. When I click the button, I want to be able to go backwards in the screen design. And we'll do this first in code, and then I'm going to show you how you can actually do it in the designer as well. But to do that, I either have to give the button a name and then wire up an event in code behind, which we could totally do, or you could do the events tab. You can go to the up inside event handler here and then put in some code there. Or another real quick way to do this is if you double click on the button, it'll take you into your associated code behind file, and then you can just hit enter to put a new button up here. Now, the downside of this approach, even though it's really easy, is it gives you these weird names here like UI button 27 touch up inside. If you don't care about that, you know, this is a sample app and you're just whipping something together, then that's maybe okay. But if you're actually trying to maintain this application, this is probably not a very good name. So let's call this on dismiss. And notice that now it's in red because this is a partial method. And so I'm going to have to go back to my main storyboard, delete that handler, and put it here. So that double click approach really is only good if you don't care about what name is given to this. Okay, but if you're trying to figure out what is the signature to put there, it is a nice way to do that. So I'm going to delete that little bit of code. Now let's put some additional code into this code behind file in order to kind of manage that email. So I'm going to go ahead and put a public property on here of type email item. And I'm just going to make it a get set handler here. And then I'm going to use the Alt Enter or Option Enter on the Mac to use this refactoring create backing store. That'll give me an actual field that backs this. You can get the same support if you have something like ReSharper installed in Visual Studio, and it may be that Visual Studio 2015 has that refactoring as well. I've not actually looked to see. But Visual Studio 2013 does not out of the box. You need some additional third-party piece to do that. You can, of course, just type this out as well, and that works. And the idea is, when we set this item, I want to set the email into that label. And so I'm going to put a method here. I'm just going to name it update item. And this method obviously doesn't exist. And so again, I'm going to use one of my refactorings here by clicking Alt or Option Enter Return on the Mac and say create method. This refactoring does exist in Visual Studio, so you can do the exact same thing. It's just either Control Enter or Alt Enter to get to this, and you can use this update item. And what we'll do here is we're going to say, do we have our email item, the email details that we created? So if this exists, this field that maps to that UI, so if that's not null, then let's go ahead and check to see if we have one of these items, and if so, let's just set the text of that item to this details, or let's set it to empty. So we'll say email details dot text is equal to item not equal null, and we'll just say item dot toString or an empty string. Now we could get to this one of two ways. When we set this item, we want to go ahead and update the items, but we also want to do it when the view is displayed. And so let's go ahead and override the view will appear method. So this is called just before the view is actually visible. And we'll just call our update item here as well, just to be able to see these update details. And so when the view appears, we'll update the details, or if we happen to change the item while this is visible, then we'll also update the details. The last thing that we need to do here is we need to dismiss this view controller. And so we can do that by calling dismiss view controller or dismiss view controller async. Either one will work. And I'm going to just pass in a null for my action. Now notice I don't have to tell it where to go back to, because the system will just figure that out. This kind of assumes that we presented some view controller from somewhere in the system, and this is just going to go back to wherever we came from. And so if that's a navigation stack, then we could dismiss from that. If this is a modal view, then we can dismiss from a modal view. Either one will work. We just simply have to call this. So we've done all we need to do in our details view controller. Now let's see how we can get to this details view controller. So I'm going to go to my table view controller here, and I'm going to go ahead and override the row selected method. Now, row selected is called when we tap on a row, and it's going to pass us the table view and the index of the row that we've just tapped on. And so the first thing I'm going to do is go grab my email item for that row, and we're just going to use the exact same code we do in getCell to go pull that email item. The next thing I want to do is when we select a row, I want to go to that details screen. And you might remember in the storyboard that on the details screen itself, if we go look at the properties for this, we gave this a storyboard identifier. And so what we need to do is go get the storyboard for the system. So we'll say storyboard is equal to UI storyboard from name. The name of this storyboard is just main. All right, so you can see that's the name of the storyboard over here. And we can just pass in null for the bundle. So that just says use the application bundle. That gives me back a storyboard. I can then create my details view controller from that storyboard. And so it's just this instantiate view controller, and it takes the string identifier from the storyboard for the view controller that we want to create. That's just our details view controller. That's this value right here, storyboard ID. Okay, it's not the class, it's the ID, and those can be separate. I name them the same just for consistency so I can kind of mentally identify to it. Now this is going to just create a UI view controller. So if you look at what comes out of this, it's just a UI view controller. So typically what we'll do here is we'll go ahead and cast this to our actual view controller, so details view controller. That way we have something that that's typed that we can work with. Once I have that, I can set that item to the email item. Then we can just go ahead and present this view controller. And we're just going to pass in the details view controller. We're going to say we want it to be animated, and I don't need a completion handler. And so there we go. We now have our details view controller created from the storyboard. We set the email item. We then call present view controller to actually transfer control from this current screen to the new screen. So let's give this a shot and see what happens. So we get all our data. I tap on a row, and you can see that it actually comes up here. And we have a little bit of a bug in that because I didn't give this a bigger height, it only has it's only capable of displaying one line. So we'll need to make this a little bit bigger. But when we tap the go back, you can see that the screen is dismissed and we come back. Now, we've got our navigation in here, but there isn't anything visually evident in the table view that says, hey, you can tap on these rows and it shows you some details. So let's fix that. We can go to our cell, and if you remember from the lecture portion, we can set the accessory to a cell accessory, and I can set it to a disclosure indicator. This will then add a little bit of UI to the end of that row to indicate that we can navigate from that row to some sort of details screen. And so now you can see that we get our little detail disclosure here to be able to tap on it. We get our view, we can click go back, and it comes back to this. Now in the lecture, we also talked about a second form of this, which was the detail disclosure button. If we use this, it's going to give us two pieces of UI at the end. The first is our detail disclosure, just like we just saw, but the second is this little button here. And notice when I tap on the button, it's not activating that row selected. This is an independent piece of UI that we can put an independent trigger on. So as an example, we could come in here and we could say override accessory button tapped. So that's the method that gets called. We don't care about the base implementation of this. We get past the table view, and of course we get past the index path. And what I'd like to do here is just present some kind of UI, like an alert. And we could use UI alert view. That's the old school iOS 7 way to do this. Alternatively, there is a new UI alert controller that we can create. And we can give it a title, we could say email, we can give it a message. So let's just go grab our email item itself. Paste that in here, so we'll just say email item.subject. In fact, we could say email item.subject and email item. So item.body, and then we can give it a preferred style. And we'll make this an alert. Then once you have this controller, you can add actions. And again, there's a little factory method for this, and we'll just create an OK button to dismiss this. The action style will be default. Notice it also has a cancel style as well as a destructive style. And then we can give it a handler. In this case, I really don't care about the handler, so I'm just going to pass in null for that. And then we're going to do the exact same thing we did earlier, where we just present this controller. I pass in the controller, I pass in that we want it to be animated, and I give it a null for my completion handler. And then this will display this alert for me. This is the iOS 8 way of doing it, and the advantage to using this is that this sort of consolidates both the action sheet approach as well as the alert approach. So we can get both the message box style as well as a pop-up sheet with a series of buttons. Let's go ahead and run this. And so now you see I have all my pieces here. I can still tap on a row. I can end up in my details view, or I can tap on the little alert item or the disclosure button there, and then you can see that I get my email here as well as a full alert view. I can click OK to dismiss that. Now I promised that we'd fix a couple of things in the storyboard. So first, let's take this label and let's just make it a bit bigger. So I'm going to kind of expand this out a little bit. We've got it centered right now, which is fine. But what I'm going to do is go ahead and set it up so that we put in a couple of additional constraints in here. And really what I want is just a height constraint, kind of like we did with the button. So I'm just going to set a height constraint on this. And right now it's going to be centered, although it'll take up this whole space because it'll grow here. But we could actually fix that as well. We can create a pin spacing and put it onto the edges here. And so notice, because we stuck it on the edge here, now it looks like it's correct. And I can do the same sort of spacing on the other side here. This will allow the label then to have multiple lines, and we'll see kind of the full effect there. So let's just run that real quick just to make sure that that works properly. And again, you can go through the IOS110 class where we kind of go through constraints and auto layout, and you can get a better sense of how all of that works beyond just this little demonstration that I'm doing here. So I tap on a row, you can see now that I have my email message here. That's great. The other thing that I want to show you is, right now we set this up to actually dismiss from the button itself. And we did it in code behind. And this is perfectly fine. This does work, but there is actually a way to dismiss this right from the storyboard. And so, just as an example, let me show you that. I'm going to go to my table view here, and the way this works is we create just a method here, an action style method, and we can call this unwind to TableView controller. And the method that we have to create here takes a storyboard segue. We don't have to put anything in it. There's no requirement in terms of implementation, but we do have to decorate this with an action attribute. And I'm going to give it the exact same name, and we're going to put a colon behind it to indicate that it has a parameter. This name is what we're going to wire up to Objective-C, or at least the Objective-C runtime. And this method has to exist on the table, or rather on the view controller that you want to go back to. All right, and so here's how it works. Once you set this method, we can go to the storyboard itself. We can take this button, and if you hold the control key and drag, you can drop it on this scene exit button that's in the bottom here. And notice that we'll get what's called an action segue. And it'll list all of the methods that have that action decorated on them. And we can click on one, and it'll associate it to this particular method. And because it's in that TableView controller, that other view controller, that's where we'll actually dismiss to. And so I'm going to take my button, go to the events, and I'm just going to go ahead and get rid of this on dismiss. So I'm going to delete that handler from here. So that button will no longer invoke that handler. And let's run it one last time here. Oh, and we need to comment this out because it no longer exists. And so you can see my data comes up. I tap on something, it comes up. Now we're doing that programmatically, but when I click the go back, notice it gets dismissed, but that's being done completely through the storyboard. So it's the storyboard that's managing that dismissal of the presentation view that's been created for that details view. Now there's one last thing that I actually want to fix here, and this has been bugging me since the beginning. Notice that my table view is actually sitting on top of the carrier bar. This is an iOS thing, or iOS 8 thing. Actually, an iOS 7 thing is where they added this, and this is because of the full screen design that we get with apps these days. What we can do to fix that, if it annoys you as much as it annoys me, is you can go into the TableView controller and you can set what's called a content inset. And so I'm just going to go ahead and override the view did load. And in the view did load, let's go to the table view and let's set the content inset, not the scale factor, but the inset to be a new UI edge in insets, and this takes a set of values, which is the inset that we want to push the table view in by. And so it's really this top edge that I want to mess with. And so I'm going to go ahead and say push it down by 20. The left, right, and bottom I don't care about. But we'll go ahead and push that down by 20. That happens to be the size of that little bar. And now notice that we're not sitting on top of that carry bar. That looks much, much better to me. I think that's great. So we've done several things here. We've supplied a segue in code to be able to navigate to a second screen. We're then dismissing that using a storyboard, but you also saw how to do that in code. We added in an accessory view on the right-hand side to show that we can navigate to another screen, and we created a detail disclosure button accessory that allows us to then display the details of a single email through an alert view. So now you've seen how we can add a table view into our application, how we can customize the cell that's being displayed to visually represent our information, and now how we can add in interaction behavior. We have one more thing that we want to talk about. The final topic that we're going to cover is an important performance optimization that you'll always want to make sure that you utilize when you're working with table views, called cell reuse. So we're going to look at three things. We're going to define cell reuse on the table view. We're going to look at how we can participate in the cell reuse system on the table view, so what methods are called and how we actually perform the reuse operation, and how we manage the cell data when we've implemented this technique. Mobile devices have changed dramatically in the past few years. Today we have multi-core 64-bit devices with all kinds of sensors sitting in our pocket. However, as awesome as these devices are, they're still not desktop computers, and they don't have the memory or the resources that desktop computers do. So one of the constraints that our applications will often have is a memory constraint, and we've actually got a pretty nasty bug in our application right now. We've just been creating a new cell each time the table view requests one, letting old cells get collected by the garbage collector and then reclaimed by the Objective-C runtime. However, this is a very inefficient approach, and on older devices will almost certainly show up as stuttering as we scroll through the items. In fact, we might even get a crash when we run out of memory. It's very possible. You probably won't notice it on a simulator, since the simulator uses the desktop CPU, which typically is a really nice 64-bit Mac OS process, and the full mono runtime with the full GC. So it has access to all of your memory, and it can handle pretty much anything that you throw at it. But physical devices will often start to fail in odd ways, or just perform badly with the approach that we've taken with the table view up to this point. So what we need to do to fix it is implement cell reuse. This is sometimes referred to as UI virtualization, and on some platforms it just happens automatically. In iOS, we have to participate with the virtualization by using specific methods to create our cells, rather than creating new objects each time. The idea is shown here on the graphic on the right. We can only display a certain number of rows at a time, and so iOS will create a set number of cells to display, and then as we scroll data, it will reuse these cells rather than creating new ones. This keeps the memory pressure constant because we're no longer allocating and deallocating cells as we scroll through the data. So let's look at what it takes to implement this. The key to the cell reuse solution is to associate a reuse identifier to our cell style. Remember that we can use multiple styles in our table view. Each row is decided independently as getCell is called. However, in most apps, there are only a few styles that you'll actually use, perhaps even just one. So the first step is to determine how many unique cell styles we're using in the application. This includes the actual cell style, as well as any visual changes made in the colors, fonts, and alignment. We then assign a unique string for each of these cell styles so we can associate a created cell to a pool that's going to be maintained by iOS. This unique cell string is referred to as the cell reuse identifier, and it can be assigned either through the storyboard designer or through the UI TableView cell constructor. The storyboard designer in Xamarin iOS or in Visual Studio actually lets you change most of the properties we've been doing in code up to this point. When you have a table view in the design, the system creates a prototype cell, which is displayed in the table view. This is most easily seen in the document outline, but you can see it in the design surface as well. If this view is selected, then the Properties section will let you change the style, set an accessory, and most importantly, assign a cell reuse identifier. If this is assigned a value, then the system will register this cell prototype under the reuse identifier, and we can ask iOS to create new cells by copying this prototype cell, so that any properties we set in the prototype will already be assigned when iOS hands us the cell. So for example, we could set the cell style, the selection color, and the accessory type, and then all of these values would already be set when we request a cell named plants as indicated by the reuse identifier. You can add multiple prototype cells in the table view, allowing you to design multiple cell styles. We'll cover that in more detail in iOS 2.15, which covers creating custom cells. We can also set the reuse identifier in code. This is the second parameter to the constructor that we've been setting to null up to this point. Again, this just needs to be a unique string, and we want to use the same string for any cell that we create that uses the specific style that it represents. The strings are case sensitive, but they don't evaluate to fields or properties, so you can have embedded spaces or whatever values that would not translate to a valid field name. To actually request a cell from iOS, we use the DQ reusable cell method on the table view. This is most often done in the getCell method. We pass the cell reuse identifier, and iOS will look in the reuse pool associated with that value and return you a pre-created cell if one exists. Now, there's an important distinction between a code-created cell and designer-created cells here. If you use the designer and create your cell and assign a cell reuse identifier, then iOS will already know how to create the cell since it's been registered from the designer. In that case, if there is no cell in the pool, because they're all in use or we're still filling the first page of the table view, then iOS will create a new cell for you using the prototype cell as the basis. In which case, you always get a cell back and you can just fill in the details. However, if you don't use the designer, and you're doing it in code, then the DQ reusable cell method will return null if no cell is available. Because the system doesn't know about the reuse style, there's no way for it to create it, and therefore we'll have to do that generation on our own in code. In that case, you'll need to test the return value and create a new cell, assigning the cell reuse identifier in the constructor and setting the cell up exactly the way you want it to be. This is where we'd want to set colors, fonts, layout, etc., things that we would only have to do once. And later, when we're scrolling, the cell will return an existing cell back from the call, and we can just assign the data. Remember, the test is unnecessary when you use the designer to assign a reuse identifier. It's only required for the code-based approach, as you can see here. Next, we fill in all the details of the cell. You have to always set all of the subviews, including clearing subview values if they're not used, because this cell may have been used in the past to represent a previous row, in which case it's still going to have those old values present in all of the subviews. That's going to be very confusing as you scroll through the cells if you don't clear those values and reset them to the proper values based upon the current row of data that we're displaying. So you either need to clear the data if it's not applicable anymore, or set new values each time. However, you don't have to set up fonts or colors. Those can all either be done in the designer as part of the prototype cell definition, or in the code when you create the cell the first time. Once it's been cached off, those colors and fonts and things will just simply be set to the proper values when you retrieve it. The only exception would be if, for some reason, the state of the data actually changes those colors or fonts, in which case you would want to go ahead and change them each time here, just as we're doing the data. So just at a high level, cells are going to be created initially for the first screen of data. So as long as you have enough rows to represent a single screen of data, the system will call your getCell method each time. You'll call DQ reusable cell, and it will either return you a prototype cell if you use the designer, or it will return you null. If you get back a null because you're using a code-based approach, then you're going to create a new cell, set all the colors and fonts and layout appropriately, and then fill in the data and return that cell back to iOS. As the user scrolls through data, once we've populated cells to represent a full screen, DQ reusable cell will start returning cells from prior rows, in which case we only have to change the data that's actually changed for that row, and then we return that cell back to iOS. This approach is called cell reuse, and it essentially keeps the number of rows that are being visually presented to a minimum. So we only have enough rows for the visual data that's actually being shown on the screen, rather than creating a cell with all of its data for every single row in our data set. This is a much more efficient approach to managing our data. So let's just test our knowledge. Question number 1. The getCell method is used to A. Create sections in the table, B. Return an integer count of the total number of rows that the table should display, or C. Return a UI TableView cell populated with data for the corresponding row index passed to the method. And the answer, of course, is C. The getCell method is used to return a UI TableView cell populated with data for the corresponding row index that's passed to the method. Question number 2. Displaying hundreds or even thousands of rows in a table view requires the code to A. Register a reuse identifier for each unique cell type, B. Use a custom dictionary, C. Always use DQ reusable cell, and or D. Set all the UI TableView cell subview properties in getCell. And the answer is A, C, and D. When you display hundreds or even thousands of rows of data in a table view, by the way, thousands of rows would probably be a little too much for the user to scroll through, but say 100 rows, then your code needs to register a reuse identifier for each unique cell type. You must always use DQ reusable cell to participate in the cell reuse algorithm, and when you retrieve the cell, you have to set all your subviews to the appropriate data that represents the cell for the row being displayed. So as a last step, let's go ahead and implement cell reuse in our application. For this final exercise, we're going to go down here to exercise 5, implement cell reuse. And here's the challenge. You're going to do cell reuse in both code behind, where you have to create the cells, and in the storyboard designer. And so you'll assign a reuse identifier. Remember, this is just a string that you decide upon. And when you create the UI table cell in code, you'll supply that reuse identifier instead of the null value that we've used up to this point. You'll then go ahead and use the DQ reusable cell method off of the table view to request that cell, and if it's not present, then you'll create one. Then you'll fill in all the details and hand it back to the table view. If you're in the storyboard designer, we'll go into the cell itself, set all of our properties directly in the designer, and then assign the reuse identifier there. Remember that when you use the designer, you don't have to create the cell yourself. Instead, because it's registered with the system as part of the storyboard itself, then the system will automatically inflate the cell for you, and then you can just fill in the details. So use these high-level steps to work through the lab exercise, and again, fill in all the details with the step-by-step instructions below. And when you're finished, come back and we'll walk through the exercise together. Here we are in Xamarin Studio, and we're going to implement the cell reuse logic both as a code behind approach and then as a storyboard approach. So let's start with the code behind approach. I'm going to open up the TableView controller, and I'm going to go to my getCell method. My getCell method currently is passing in null for that second parameter. The second parameter is the reuse identifier. So if we look at the constructor, you can see it takes a string as the reuse identifier. In fact, all of the other constructors actually take this. So you can see here's another one that takes a cell style with the native string from iOS, or rather from the Objective-C runtime, NS string. We can just use the C# version here. And so the first step is to just decide what our cell identifier is going to be. I'm just going to create a constant string here for that, and let's just call it mail cell or email cell or something like that. We'll call it cell ID. And then I can pass in this cell ID here. Now, this in itself is not going to implement reuse, or rather it will, but we're not taking advantage of it yet. And so the very first thing that we need to do is actually request one of these cells from the table view itself. And so we'll say our cell is actually equal to TableView DQ reusable cell, and then notice we pass in that cell identifier. And because we're doing this in code, we can then say if cell is equal to null, then go ahead and create it through our constructor. And then we can set all of our things up on the cell. Now, this will work and this will implement the cell reuse. However, there's a couple of things that we're doing to the cell itself that really only need to happen once. In particular, we're setting the text color and we're setting the accessory here on every single cell as part of the construction of that cell. And so we can actually move this logic right here into the construction of the cell itself. So only when we create the cell do we go through this logic here to actually set the text colors and to set the accessory. And in the lab, you also set the font and other things. And so there's a variety of things we could actually adjust here. Now, for things that are dynamic on a row-by-row basis that are going to change, such as the text label, the detail label, and the image view, for those things, we want to continue to do those every single time. Right? So we don't want to see old stale data from prior rows, and so these are the things that we're always going to set. And in fact, one of the things that we might even want to do is get rid of this image view if we actually got one of these cells. So we're reassigning the image view every time, and if you go look at this get image method, it's actually recreating a new image each time. And so from an optimization perspective, what we might even want to do here is say, else, if we did get a cell from the DQ reusable cell, we might want to look at that image view and say if it's not null, then we might want to take that image and just dispose of it. So we can get rid of that image just so that the garbage collector can go ahead and throw away whatever older image that we already had. And so we might want to do a little bit of cleanup there as well. That's actually optional. The garbage collector would come along and pick it up and everything would be okay, but this will just make sure that we get rid of that image a little bit quicker than what we might have done in the past. So this is all we need to do in order to implement the cell reuse. We call DQ reusable cell, we give it our unique cell ID. If it comes back null, then we create a cell using that same cell ID. Now there's one other step that I want to do here just to make sure that this is all working properly, and that is let's increase the number of emails that we're actually going to start with. The default is 10. Let's put in 1,000 just so that we know we have a bunch of emails to scroll through. Then let's go ahead and run it. And so notice now we get all of our emails here and I can scroll through this list. And so you can see it scrolls. Now what I want to do is actually just put a breakpoint here. So we've created enough to actually display a full screen of data. And so I'm going to just scroll this, and I want you to notice that we're not hitting our breakpoint. That's because we're no longer creating new cells. We've already created enough cells to display on the screen, and instead now these cells are being reused as we scroll through the data. And so that's the cell reuse capability. Now we can do this exact same cell reuse capability in the storyboard itself. And so I'm going to copy my email cell ID here and open up the storyboard. Now from the lecture you may recall that we can actually do all sorts of interesting things in the designer from the storyboard perspective. So if I come over here to my table view and just click here on the table view itself, you might notice there's this little white area here. This is actually the UI table view cell itself. And in fact, if you open up your document outline, you can see that the document outline shows the table view controller, the table view that's in it, and then inside there you find the table view cell. And if we go to the properties for this cell, we could give it a class if we wanted to derive from it. In fact, that's exactly what you'll do when you customize table cells in the next class, IOS110. But we can also set a particular style on this. So for example, we could set our subtitle style, and then we can see we get a title and a subtitle. We can set our reuse identifier to email cell. We can set an accessory on this to be the detail disclosure, so we get our little button and our little arrow here. And so all the things that we did in code behind in our get cell to kind of construct that cell and set it up the way we want it to be can be done right here in the designer. And then we just give this identifier a valid value, a string here, so that in the TableView controller itself, we can, let me just comment all of this out. We can get rid of all of this code to create the cell because it's all now being done in the designer. So we know that by passing in this cell ID, we're actually getting back a valid cell. Now there's a second version of this method that takes an index path. And if you're doing things in the designer, it's a good idea to go ahead and use this version of the method where you actually tell it which index to use, because it can change the algorithm slightly based upon which row we're actually populating here. It'll work either way, but this is just a newer form of that method. And so we can use that index cell here. So we still need this code here to actually get rid of that image if we'd like to keep that optimization in place. And so let me just uncomment this out, except we only want to do this if the image view image has a value. So not only do we want to make sure we have an image view, so it's set to subtitle or at least not value 2, but we also want to test to make sure that that image has actually been assigned. So let's go ahead and run this and see what happens. And so you can see we're getting all of our values here. I can still tap on a disclosure indicator, I can still tap on the row and get to my second screen, and you can see that I have all my data and it scrolls fairly nicely here. So we're taking advantage of cell reuse now from the storyboard. Now I mentioned in the last exercise that there's one other advantage that we get out of assigning a cell reuse identifier from the storyboard perspective, and that is we can actually get rid of this row selected code here. So I'm going to comment this row selected code out. I'm going to go to my main storyboard, and what I can do with this is if I kind of zoom out just a little bit here and maybe even move this view next to this, we can actually hold the control key and click on our TableView cell and drag and drop it onto this other view controller. And notice it gives me this pop-up here that asks me what type of segue would you like to create. I'm going to create a presentation segue. That is exactly what we did earlier. We just did it in code behind. And so now what we can do is we can actually select this presentation segue. And again, selection gets a little bit quirky if you're not in a one-to-one ratio, so go ahead and zoom back out to a 1-to-1. You can select this, you can give this an identifier, and you can even set some properties on here. So how do you want it to be displayed? What kind of transition would you like to use? Cross dissolve or partial curl, something like that. So let's call this show details. So that'll be my show details segue. And remember that we used an exit segue to get back from that button to take us back to the table view. Now we're going to go ahead and when we tap on that row, take us to this segue here. So it'll automatically do it, and we no longer need to have that row selected. However, the row selected was doing a second thing here, which was it was setting the email item. And we still need to do that. So we would go into that second screen, that would work. So if I just run this, you can see I get all my data. I can tap on one. It does take me to the screen, but I no longer get my email details because we're not setting the email details. So the way that we can do that is there's a couple of other overrides we can catch here. So remember we used that unwind to TableView controller with the action. Well, these are actual overrides, and one of them is prepare for segue. This is called before the segue actually occurs, and it passes us the segue in question that's actually happening. And so what we can do in this prepare for segue is we can say if the segue is equal to the show detail segue. So if this is the one we're interested in, and we only need to do this test if we had multiple segues, but I'm going to kind of assume that we do. Maybe we do, maybe we don't. Then what we can do is we can go get the details view controller. So I'm going to actually copy a couple of things out of this other method here. So let's go ahead and grab our email item. Now, notice we don't get an index path row here. However, we know that the way that this segue just got created, let me actually put it inside this show details. We know that when the show details segue was run, that it was actually as a result of a row tap. And so what we can do is we can go to the table view and we can say, what's the selected row right now? And then we can take that and pick up the row. So this will hand us back an index path, and we can go grab the row, and that will give us the email item. Then the other thing that we want to do here is we want to go and grab the details view controller. Where we can get that is right off the segue. So notice that the segue has a destination view controller and a source view controller. Where are we coming from and where are we going to? So the destination is where we're going to. That is our details view controller. Once I've got that, we can say if details view controller is not equal null, then details view controller dot item is equal to email item. So we can just assign the item right there. We don't need to do anything for the segue itself. By simply returning from this, it'll automatically go ahead and continue the segue response. So we don't even need to call the base here. So now I tap on an item. We get our segue, and notice now I get my email, because the prepare for segue is identifying the details view controller from the destination view controller, going and grabbing the selected email item based upon the selected row that we tapped on, and then setting that item so that we can get there. And then we can, of course, click go back, which runs the exit segue and gets us back to the original screen. And so now we no longer need this row selected. Now I show you this only to kind of complete the picture of a way we could do this with the storyboard. To some degree, I think probably having row selected being overridden is a little more intuitive from a code perspective, but you can choose either approach. Either is perfectly valid. If you prefer to work predominantly in code and like to see kind of the transitions occur in code, then override row selected. That's a fine approach. There's nothing wrong with it. If you prefer to be more of a designer type person, you can push most of this logic into the designer and get the designer to do it. The advantage to doing it in the designer is you can kind of get a graphical picture. If we zoom out, we can kind of see where screens are going. So I can see that this screen goes to this screen. If I click on this or look inside the document outline, you can see that we get a presentation segue from the table view over to this other view controller. And so we can kind of get a visual sort of view of how my screens are connected, which that can be valuable to some people. So that's not a bad thing. So now you've seen how we can implement cell reuse both from the code behind perspective as well as from the storyboard perspective. And the approach is very similar. The key piece to this is that when you actually are retrieving a cell, you always go through this DQ reusable cell, and you use the cell reuse identifier, and you have to make sure that it's the same cell reuse identifier. So we want a unique cell reuse identifier for each unique cell that we're trying to represent visually. So in this case, we only have one. Every cell looks the same from the perspective of the data that we're putting in it. But if I had multiple cells, maybe I have one that's a high priority email and I want it to visually look different, then I might have a second cell definition with its own unique cell identifier, and I would then retrieve that one if I detect that this happens to be a high priority email. So let's go wrap up in the slides. So now you've seen how to add a table view into your application, how to select a specific cell style to represent the data that you want to show, how to provide navigation or interaction capabilities by overriding methods on the TableView delegate, and then now how to properly implement getCell to efficiently manage the cell visuals so that we aren't creating cells every single time, but just using a pool. So now you've seen the fundamentals of working with table views. You've seen how to construct them in storyboards as well as do them in code, and how to then connect them to other screens. But there's two other classes that Xamarin University has that will extend your knowledge of table views that I encourage you attend next. The first is IOS110 that's going to look at other customizations you can do specifically around TableView cells. And so we looked at just the basic cells that are included with the TableView design out of the box. IOS110 will then explore how to create custom cells so you can create whatever visualization you need in order to properly display your data. The second one is IOS215, which looks at adding some editing features into TableViews. So this class just explored read-only data and being able to present data and then navigate to a second screen, but sometimes you'd actually like to edit that table view, add new items, remove some items, reorder items, and that's exactly what iOS 2.15 gets into. So make sure to check both these classes out to further your knowledge about how to use TableViews in iOS. So thank you for being a subscriber to Xamarin University. I hope you've enjoyed this video on the fundamentals of TableViews. If you have any questions, feel free to email me. My email address was listed on the very beginning slide. Or you can post some questions into the forums where we have all of our instructors that can engage you with any questions you have on using TableViews in iOS. Thank you, and I hope you have a wonderful day.